Welcome to the 5th or the 6th Google Hangouts on Air show. This show is hosted by the Google Developer Experts team from all around Africa. And today we're going to be talking about the Android architecture components introduced during I/O this year. So just a bit of context of who we are. I'm Rebecca Franks, and I'm part of what we like to call the Google Developer Experts program. And Google Developer Experts are people that are recognized within the industry as experts and leaders in various different Google technologies. So I'm one in Android, and we have other experts joined with us that are cloud and web GDEs. So this show is basically going to be hosted monthly, and it's a live Hangout on Air where you can ask your own questions or give your feedback around what we're presenting on. And then after the show, there'll be a video to watch on YouTube later, which is quite cool. So the aim is not just to host GDEs. We want to be hosting different developers from around the African continent at first. They will be presenting as well on the show. So next month's Hangout, we already have 2 people that will be speaking. And that's a talk on Kotlin presented by Moheen and Segun from Nigeria, which is quite exciting. If you want to get involved in the conversation, you can tweet us on Twitter with the hashtag Google Africa Devs. And at the end of the show, we'll be answering some questions that have been asked on the live chats on YouTube or on the Google Plus event itself. So we'll be monitoring that and making sure that we can get to some of the questions that you ask. So with me today, I have a couple of the GDEs from around Africa. So I've got Alex Koller from Cape Town. You can see him shining in the corner there. We've got Dale Humby from Cape Town as well, Cloud GDE. We've got Dario Mangoy, Android GDE from Mozambique, but currently based in Canada. And we've got from Google, we have Vivian Akinyi, who's part of organizing the Google Developer Experts program. And like I said myself, my name is Rebecca Franks, and I'm from Johannesburg, South Africa. Cool. So we're going to jump right into the presentation. So give me a few seconds to set up, screen share. Screen share. All right, so today's presentation is going to be looking at an introduction to the Android architecture components libraries. Just a little bit of the agenda about what we're going to cover today. So we're first going to have a little introduction, then we're going to have a look at Room, very brief look at it. Dario will be taking us through that. We'll be having a look at live data as well, and then we'll look at view models, the lifecycle classes that have been introduced, and then we'll have a little quick summary of the whole show. So if you want to follow any of us on Twitter, you're welcome to do so. So I'm at Riguru on Twitter. You can follow Dario, who's at Dario Mangoy, or you can follow Alex, which is Alex Koller Dev on Twitter. So what are the new Android architecture components? So they're basically a bunch of best practice guidelines for writing Android applications that have been released. And these different components, they can work really well separately, so you can use them on their own. But they're really, really powerful when you put them all together. And they were released at Google I/O 2017 this year. They're currently in alpha at the moment. I think we're on alpha 5, if I remember correctly. But the team is really working quickly and releasing, I think, every week now. There was a new version this week as well. So there's a lot of changes coming in, a lot of feedback that they're getting from developers and putting it into these libraries that are being offered. So today we're going to have a look at all these different components and hopefully help you understand where you can use them and how you should use them and how you can use them all together. So one big thing to note about these libraries is that they're what they like to call a sign, not a cop. So they're not saying that this is the only way to write your Android apps from this point on. But it is a good set of guidelines for you to follow if you are not sure as to how you should be writing your apps. So if you're really into writing your apps with using the MVP pattern, or you like doing clean architecture pattern, you don't have to go and change it into using this model, but these are some good guidelines for you and might help you solve some complex problems that you've been experiencing before. So why exactly were these components introduced? So there was never any advice given around how to architect an application. So there was a post a while ago on Google Plus from Diane Hackborn where she said that a lot of people were asking around how do I architect my app, and I don't know how to do this. Can Google provide me some advice? And back then the answer was that Google doesn't provide this advice, but you can do it however you want. We just give you the platform to do it. So subsequently this has changed now, and now the advice is more of a best practice guideline, and it's not a strict guideline. It's not to say that you can't do it any other way. But now the Google team has realized that there is a need for this kind of input from Google. So they are giving that for developers to use now. So they also provide some helper classes to handle some common scenarios. So for instance, lifecycle challenges that you've had before, and the issue of handling different screen rotations has also been quite an issue, and there's a whole bunch of different solutions for it, but there's never been like an official way or an easy way to handle it. So these classes aim to help you solve these kind of problems. They also aim to improve the overall quality of apps. So there's been a lot of applications that typically just everyone sort of writes their app, gets it to work, but there's no sort of architecture that's been followed. There's no sort of tests that have been written. And generally the quality of the code and eventually the app itself is not so good. So overall, these libraries aim to improve that going forward. Okay, so there's a couple of different components within the architecture libraries that we will be looking at. And there's the 4 that we're going to cover today. The first one being Room. So Room is what we call a SQL object mapping library, and it's very similar to ORM Lite or Greendale if you have worked with any of those in Android before. But basically it eliminates the need for cursors. You don't have to do that kind of horrible work that you had to do before if you can just use Room. So Dario will be going into a little bit more detail about Room in a moment. The next one is Live Data. So Live Data is just a data holder that can keep a value, and it allows you to observe these values and wait for them to change and get updates and that kind of thing. And this also just respects the life cycle of your application. We also have view models. So these store and manage your UI data, and this will also survive configuration changes, which is actually quite interesting. And Alex will be going into a little bit more detail about that later on in the show. And then we have the lifecycle classes that have been introduced. So these are classes that can help you manage your lifecycle correctly. I'll be going into a little bit more detail around how you can use them and what exactly the most benefit you get from them. But those are the 4 different components that we'll be covering today. And so how do you actually, okay, so what we're going to be looking at is we've got a sample app that you can use. If you go to that link that we've got broadcast at the moment, this is just a very, very simple app that shows a list of dates that a user might want to count down to. So in this example, I just give it a title. I set a date that I wanted to count down to, and then the list tells me how much longer until that event. So throughout this presentation, we'll be referring to the code in that within the context of this application, if that makes a bit more sense. Okay, so this diagram is probably a little bit daunting at first, but bear with me while I sort of try to explain how this whole thing works. So typically when we're using the architecture components, when we're using them all together, a very good architecture that would work well with it is what we call MVVM, which is a little bit different to MVP, but the main difference is that with MVVM, you are publishing information to whoever is subscribed, and with MVP, it's more tightly coupled. So it is very tightly coupled to the view. So in this example, you'll see we have a database file, and this is what we will use. On top of it, we will use Room. So we will use these annotations, which Dario will go into a little bit later. And basically, on top of our database, we get these nice interfaces called our event DAO and our event database. And then what we would put on top of it is what we call our event repository. So the repository is sort of responsible for deciding, do I get something from the database, or do I go to a network call to go and fetch the information? So this does a lot of the sort of heavy lifting and the logic around where to get information from. And then if we're looking at this, the certain views, so if we're looking at the add event or the view list of events view, we would typically have one view model. So we have an add event view model, and this would be part of the Android architecture components where we extend the view model object. And this view model would go and get information from the repository and then publish it for the fragments or the view itself to go and observe on and do changes to the view if it needs to. So we'll go into a little bit more detail around each of these separate little components, but hopefully this sort of gives you an overview of where exactly the different components lie. Okay, so how do you add these architecture components into your application? So first of all, you'd need to go to your top level build Gradle file. So in your project that you've got created, in your build Gradle file, you just need to make sure that you're including the new Google Maven dependency as a repository that you want to be to fetch your dependencies from. And then in your app level build.gradle file, so one level deeper, you're gonna, you're gonna go and add different components that you need for your application that you want to build. So for life cycles, view models, and live data, you would need to add these three different dependencies. And you can see we're in Alpha 5 at the moment, but you need to be sure that you keep updating this and checking the latest version. So this is the version at the moment, but there's obviously new ones every week, I think, or every week or so. So just make sure you're keeping up to date with that. So these are the ones for life cycles, view models, and live data. I'm going to be looking at Room as well. You would need to add the Room dependency and the Room annotation processor. All right, I'm going to hand over to Dario for a bit for him to talk to you about Room.
Okay, thank you, Rebecca, for such an amazing presentation. So if you're still with us, I have to say this presentation is a lot to cover in a short amount of time. So thank you, Rebecca, for giving us a great introduction of all the components. So I'll be spending the next few minutes talking about persistence with Room and also a little bit more about live data. But before we get started into Room details, I want us to take a look at why persisting data is important. And the first thing is that users hate to see loading screens. So when we're developing our apps, users are always expecting for great user experiences where they have the data that we requested right away. And if we provide them with loading screens, they will definitely be mad at that. The second thing is that the more we persist data, it means the less network calls we're going to do, and that is going to add into the savings of the users on their data and battery. And of course, they will love you for that. And lastly, talking in the context of a region in sub-Saharan Africa, where the internet is not reliable in all locations, we want to make sure that our app works gracefully, even on these flaky networks. There are so many solutions available out there to kind of reach the same goal. There is Firebase through the Firebase Real-Time Database Service. There's RealmDB, and also the framework has already came with some options such as the share preference, SQLite, content providers. And of course, there's Room, which is the start of the day, which are going to see how we can start using right away. So the question right now probably is going to be, what is Room? And as Rebecca said earlier, it's a SQLite object mapping library similar to ORM Lite or GreenDAO. But then it's also important to understand what is an object mapping library. So in our Android projects, we normally have Java classes that represents whichever real-world object that we're dealing with. And these objects can somehow be very complex. But on the other side, we have databases such as SQLite, which only store values in scalar values. So an ORM actually acts as an interface to kind of do this conversion. So getting started with Room, as Rebecca was showed before, the first requirement for you to get started with Room is pretty much configure your project and make sure you add the right dependencies, and don't forget to update them regularly, as this is still in development and new versions have been shipping almost every week. So after you have created your Room, after you have added room to your project, the first thing you want to do is to create an entity. So if you take a look at SQLite databases, normally the databases contain different tables which contain different columns. So these tables are no different than the objects that we already have. Looking at the context of the simple app that Rebecca showed earlier, we would have a table to store the events. And to kind of make sure that we create that table with room, we just have to our already existing event class and use the room annotation entity and specify the table name. And also one very important thing is that SQLite databases require that we have primary key so that every row can be identified in the table. So for this purpose, room also offers us with an annotation for primary key, which you can set a property to auto generation or not, depending on what is your iterate strategies. So after we have created our entity, we need to create a DAO. And basically a DAO is a contract that defines all the operations that we might want to do to a specific entity. So imagine going back to our event example, we might want to insert events, we might want to load or update them. And the DAO interface is where we define all these methods. And the first thing we have to do is to create a regular interface and annotate it with the DAO annotation. And then after that, on the methods, on the different methods that we want to perform to that specific entity, we use provided annotations by room. So as an example, we have two annotations here. One is for query, where you write the SQLite query as you would normally do for any, if you're dealing only with SQLite, or insert. And the coolest thing about room is that if by any chance you fail to write these queries, it's going to correct you at compile time. So you make sure you will be always sure that your query is going to be right. So the next step would be to create a database. And to create a database, just simply creating an abstract class and annotate it with a database annotation, where you can set the properties such as the version and also the entities that this database is going to have. So in this example application, we might have entities for events, for organizers, for performers, and many other things. And then the event database class should extend the room database base class. And also we define abstract methods to get all those DAOs. And finally, to access this database from anywhere in the application, you could create a singleton instance, or you can use any dependency injection framework to get this instance whenever you want it. So going back to our ORM definition, not all the time we have simple objects that are composed by scalar values. Some of the times we have more complex structures, and we might be asking yourself now, how do we handle that with room? So basically, room has a concept of a custom type adapter, which is pretty much an interface where we specify two static methods that define how room is going to handle from the data, from the object that we send to it, how it should be saving in a database, and back and forth. And to do that, if we take an example, local datetime class, where we'd have our event date and time in object, our database would only be able to save timestamp as a scalar value, which would be a long. So we need to define a type converter where we're going to transform, as you can see here, we can transform our data to a long, and then we return to it. And after that, we just need to go back to our entity and add the local date time field as any other field in our entity. So in order for room to know about how to do that conversion, you need to go back to our database and annotate with the type converters so that we can define that this is the type converter for a specific type, for that specific type. So whenever room gets to meet that object, or while reading or inserting, it will know exactly how to handle that case. So we kind of went through very, very fast on how to use room for basic things, pretty much how to create a database. But then There are so many other benefits from Room, and one of them, and a few of them to list them here, is that first, Room also comes with support for SQLite data relationships, which means you can, from what we saw, we can do more complex queries such as joins, and actually the custom type converter is just a solution for a bigger problem that we might have if we have more complex objects and relationships, but Room handles that gracefully. The other thing is that Room easily define multiple indexes to improve query performance, but you have to make sure that you don't overdo on indexing everything else, as it might draw back and backfire at you with some serious performance problems. The other thing is that support for RxJava Flowable, maybe, and Single. So if you're familiar with RxJava, this is some really cool news, because you can make sure you're observing data through one of these mechanisms. The other thing is, as I mentioned before, does SQL statement verification at compile time. This might be something really, that one of these things that looks really small, but if you take a look at the time that this saves us when doing these compile time verifications of SQL statements, you'll be definitely amazed about using Room. So it is designed to be testable. As you can see, or as you could see during the examples that we were showing, pretty much we have been dealing with interfaces and abstract classes which have no implementation, so we can definitely create our own implementations and mock this in order to be able to write some tests. And one more important thing is that it comes with mechanisms to do database migrations. So now that we have seen how to insert, how to persist data, I would like to take a few moments to talk about how we could do some improvements into a few things in a WOL persistent experience by talking about live data, which eventually Rebecca will talk into more details afterwards in this presentation. So basically, if you take a look at an example, the query, one of the queries that was defined in the event DAO, in this case to get an event from a specific point of time, this method returns a list of events, and whichever the component that is going to run this query is going to face some problems. If the data gets updated in the background, it's not going to be automatically updated, and it might be very hard also to listen for changes in this specific table or this specific query in multiple locations in our app. So to kind of solve that, we have live data. So basically, live data is an observable data holder that is lifecycle aware and does automatic management of subscriptions. And to use a live data, we simply have to wrap our object into a live data. And then whenever, from anywhere in our UI, we can just observe to this live data and passing it a new lifecycle owner and an observer. And whenever we start observing, we're going to receive the information that we want every time. But live data actually have a few more limitations, which I'm gladly happy to pass to Alex, which is going to take us on how to go through these limitations using a view model.
Thank you, Dario. Indeed, the view models do solve this problem. It's not the only thing, though. So let's take a quick step back and see exactly what a view model is. So in the MVVM or model view model architecture that Rebecca described at the beginning, the view model obviously plays quite an important part of that. So the key thing about a view model, the one thing to really remember about it, is that it helps you take code out of your UI components, out of your fragments and your activities, so that your fragments and activities no longer have to worry about where to fetch data from and how to fetch data. So view models in the Android architecture components is a very simple class that it's designed to store and manage that UI-related data. One of the best advantages of view models is that it does survive configuration changes such as screen rotations. So you don't have to worry about persisting all the data on your screen and having to restore it when the activity gets recreated after a rotation. The view model will just magically keep that data available. It's not quite magic, and I'll dig into exactly how that works in a few slides. Another fantastic benefit of using view models is that it's highly unlikely that you're going to create memory leaks. This is done by never referencing activities, fragments, or views in your view model. There are handy lint checks in Android Studio that will remind you if you ever are going down this path. So how do view models fit into the bigger picture? If we have a look at this diagram, which is a slightly simplified version of the same thing we looked at earlier, and if we look at it from the bottom up, you can see that we're probably fetching data from a few different sources. And we're using a repository pattern to make sure that the rest of our app doesn't need to worry about all the specifics of each data source. And instead of accessing that repository or data sources directly in our activity or fragment, we create a view model whose responsibility it is to fetch that data and manage it. Then the activity or fragment just has to worry about the view model. So the view model sits between the UI and data or business logic and results in simpler and slimmer activities. One extra advantage of this is that the view model is highly testable and encourages you to write code throughout your application that is testable. So how exactly do view models survive screen rotations? Well, you'll see in a slide or two that when we create a view model, it is scoped to a life cycle. Rebecca's going to touch on life cycles in more detail later, but the important thing is to understand that a view model outlives an activity or fragment during a screen rotation or configuration change. Basically, the framework keeps track of which view models are attached to which fragments and activities. And when the framework knows for sure that this activity or fragment is not going to be used again, it only then destroys the view model. Otherwise, it reattaches it to the activity or fragment when it is recreated. Another handy thing about view models is that they actually clean up after themselves. When I mentioned that the view model is a simple class in the Android architecture components, I meant that it only has a single method that you can override, and you don't even have to, but that method is onClear. So that runs when the framework decides that there's nothing attached to this view model anymore, and you can clean up any resources you have been working. So this is how it works, but you don't really have to worry about that detail. You can just be assured that it does work, and it works well. So one question that often comes up is, we've been using saved instance state to keep track of our data in our UI during rotation changes. So how is this different to that? Can we just replace it? And the answer, in short, is not quite. They are different, and they need to be used differently. So view models are not persisted when the application is killed by the OS. So if a user dismisses it from the recents list, or if it's killed in the background due to low memory, then the view model is not reattached to the activity when it gets created. Whereas a saved instance state is kept in the system process memory. So that means that when the app is restarted, that information, that data is available. However, it also means you should use that memory sparingly, because that's shared across the system. So the typical usage would be to store a pointer of sorts, an ID, a unique ID for your more complex data in the saved instance state. And then when you recreate your activity, you pass that object ID to your view model when you create it. Then the view model looks up the more complex data, which could have bitmaps and other large memory items in it, and then it handles the persistence of that. Okay, so how do we actually create a view model and use it? Well, this is a very simple view model, and this links back to the demo app that Rebecca showed at the beginning. On that screen with the list of birthday events, yes, it probably needs a design review, but let's not focus on that. We have a list of birthday events, and we don't want to fetch that data directly in our UI. So inside of our view model, we actually have code there to create, fetch the data. So we use our event repository and we load all of the events into a private variable. We then have a method to get those events and return them to the UI component. So that's as simple as it can get. Then in your activity or fragment, you can access that view model. So this is the onCreate method of an activity. And we use the view model providers class in the Android framework or the new architecture components. And we say that for this fragment or this activity, for its life cycle, we ask it to get a certain view model. So we can access all of our view models throughout our application code this way. And in this case, we're asking it to fetch an event list view model. It will either create a new one or it will fetch an existing one that is created of the same scope, the scope being the fragment or activity. So that's how, when an activity is recreated, a new view model is not created, but the existing one is returned from the view model providers. Once we have our view model in our activity, we can then call any methods we like on it. So we call the initialize method to make sure that the view model goes and fetches all of its data. We can then access those events at any time later in our code. So that's the simplest case. And view models can be very useful on their own, especially in terms of code organization. It can make your activities and fragments a lot lighter. It can make it a lot cleaner as to how you're accessing your data. But obviously, it's more powerful with its friends, the rest of the architecture components, especially live data. So I'm going to see how we can extend our example to see how it works with live data. So this is our same events list view model. However, we've added live data to the mix. All we've done is wrapping our list of events in the live data field class. And our get events method then returns live data. Now remember, this is observable. So what that means when we're using it is we go ahead and we get a reference to our view model as we did previously and initialize it. But then when we get the events, instead of being returned a list of events, we actually have an observable live data object returned. So that means we can observe that variable that's returned and run a method every time that that underlying data changes. So in this case, every time that the list of events changes in the database, we will be notified of that and we can use the new list of events to update the UI. So that's fantastic. Our activity here doesn't have to wonder about how to deal with data, where it's persisted, or any of that. It just has to listen to changes and show it in the UI. So that's the basics of view models, but a few more tips and tricks because there are more advanced things you can do with it. So sometimes you might need access to a context in your view model, in which case you can extend the class Android view model. And all you have to do then is provide a constructor that takes an application class for the context, and then you have access to that. Another thing you can do with view models is to actually share data between fragments. Because if you fetch a view model through the view models provider and provide the activity as a scope from two different fragments, they can return the same view model. So you're actually sharing the same view model between multiple fragments in an activity. And that means you both have access to the same data and can observe it without having to worry about callbacks and other ways of interacting between components, which always results in a lot of boilerplate code. So remember, view models help you separate your UI code from your data access and business logic. It's really a fundamental part in making sure that you adhere to the MVVM architecture and that you get very nice testable code. So we did touch on life cycles there, and I'm going to hand over to Rebecca to give you a bit more information about that.
Cool. Thank you, Alex. So like Alex mentioned, we're going to have a look at now how you can use the lifecycle classes and make your own lifecycle aware components, such as live data, which is an example of one. So how would you typically handle these life cycles? So these lifecycle methods are the interfaces that let you build lifecycle aware components. And this allows you to automatically adjust the behavior according to your current life cycle. So if your app is in a pause state, you can adjust your component to do something, and you can adjust it to any of the different states that you get back from these observers and these annotations. So it helps you avoid memory leaks and complex activity or fragment code. So the same way in which introducing a view model into your app avoids memory leaks and complex code, making your components a lifecycle aware component also helps you manage and avoid memory leaks. So with the lifecycle classes that have been introduced, there's basically two different enums that you can have a look at now. Yes, I know enums, but they're really, really useful and a lot more advantageous than not having enums. So the first enum that you get now is what we call a state enum. So that can be queried at any point of your life cycle, and it will tell you the exact state in which the life cycle is in. So you would get your initialized state, your destroyed state, your created, started, and resumed. So these this is the actual state of it, and I've typically seen a couple of implementations of people trying to do this themselves, where they've got sort of like a Boolean within the on pause method and the on resume method that they keep track of, is the activity paused, or so this is quite a nice it's a state that will tell you exactly where the life cycle is in any point in time. And then you also get the event enum. So this happens, these event enums obviously are events and not state, which actually makes a lot of sense. And now what we get with the events is all these different on create events. You'll get the on start event, the on resume, on pause, etc., etc. So with these two different enums, it makes it a lot easier to handle your different life cycles within your own components. And we'll see that now. So, the old way of kind of handling state was, if you can think of, for example, if we have a video player, and in our activity we have this video player that needs to sort of play a video, and obviously we don't really want this player to be playing when the user's devices, maybe they've turned their screen off, or they've exited the app, or they've just paused the app, or they're going to another app. So we would probably need to, in our on start and on stop methods, we would probably have to start calling our own methods on our video player to say, start the player or stop the player. So this might look okay at first, but as soon as you start adding more and more components that need to do the same sort of thing, it can become quite tricky to manage and make sure that they're actually working as expected. And as a developer, when you're creating a component that other developers will use, it can be quite tricky to now start to write the documentation to make sure that everyone always puts this in the on start method and they don't put it in the on stop, or they don't confuse the life cycles that they need to insert their code into. So this is the old way, and now we don't have to do it this way. So there's a much nicer way in which we can do it. And this is what we call making a life cycle aware component. So typically all we need to do is create another class. So in this case, we're calling it a video player component class, and we're implementing the lifecycle observer interface. And now what we can do is, this lifecycle observer interface doesn't actually have any methods, but when you start to implement it, you can then annotate any methods of yours with the on lifecycle event annotation. And any of those different event enums that we looked at earlier, you can then annotate it with that. So in this case, the onStart event will trigger and run the code that we've put in the onStart method that we've got here. So you can do this for any different type of the event enums. So on create, on destroy, and then it'll run the code within there. And an example of how you can use the state, you can, within any method that you run within the component or on the lifecycle itself, you can query the current state and then check that it's at a certain point or it's equal to a certain state. So in this case, we're just checking, is the lifecycle in a state that means it's at least started? And then we can do some sort of logic over here. So this is also very useful for making sure that your code remains within the component itself and it doesn't sort of go to the activity, and you don't have to manage certain things within the activity itself. So one very good example of a lifecycle aware component is live data, which is what we've spoken about this whole presentation. So live data is basically a lifecycle aware component. And if you go and dive into the source code of live data, you'll see that how they actually implement and manage the lifecycle. But basically, the live data component manages all the subscriptions and that, so that you don't get callbacks when your activity is destroyed or anything like that. So you avoid a lot of the typical issues that you might have gotten before, where you had to like unsubscribe from things or make sure that things function they do when your screen goes into a destroyed state. So the lifecycle owner class is also quite an interesting one, and it's basically a single method interface that indicates that a class has a lifecycle. So the get lifecycle method must be implemented by this class. And two examples of the lifecycle owner at the moment are the lifecycle activity class and the lifecycle fragment class. And these both implement the lifecycle owner interface. And a very important thing to note is that these two classes will be deprecated when these architecture components are released publicly to, when they're out of alpha and out of beta. They will be replaced, and the normal support fragment and app compact activity will implement the lifecycle owner interface, and then you won't need to use these two classes. So typically you won't really be implementing your own lifecycle owner unless you're doing something crazy, but you would probably just use the ones that are provided for you by the support libraries or the architecture components libraries. Okay, so an example of using a lifecycle owner, so we can go back to the example of a video activity here. And this activity now, we are extending the lifecycle activity, and this then provides the lifecycle owner, and it provides the lifecycle information about this activity. So now, in my onCreate my activity, all I need to do is get this lifecycle and add an observer onto it. And the observer that we're going to add is the video player component that we created a couple of slides back. So now what this will do is it'll make sure that the video player gets all the callbacks for the different methods. So when onStart runs or onStop, the video player component will be aware of that, and it will make the necessary adjustments that it needs to. So I no longer need to go and implement the onStop and call my player to stop the player, or onStart. I don't need to manage any of that. The component itself will take care of all of that for us, which is pretty nifty. All right, so that's a very, very quick introduction about life cycles. And I'm going to hand over now to Dario to just do a quick summary of what we've covered today.
Thank you, Rebecca and Alex. So I think we are at the end of our show. We're pretty much, I mean, when it comes to content, the show is not over yet because we're still to answer some of your questions. But first, thanks, guys, for bringing us with such amazing content. And I know it's a lot to take in, and you probably have to take some time to digest all this information afterwards. But to kind of do a summary of what we were talking about today. So basically, architecture components are a welcome addition to Android. And the reason why they're a welcome addition to Android is that they help us solve complex problems like screen rotation and lifecycle management. If you have been developing Android applications for a while, I think that you have probably spent a lot of your time trying to understand the activity, the lifecycle diagrams. So if you have that figured out, please afterwards let us know how you did that. But chances are that you're probably struggling with that almost all the time. So the other big problem that architecture components come to help us with memory leaks and exceptions due to being in an incorrect state. Again, if you have been developing Android apps, so for reasonable time by now, you probably had encountered that illegal state argument, illegal exception state, whatever. It's an exception. It's bad. And the last thing is that it simplifies code, make your code cleaner and easier to test. Yay to testing, because that's a very huge win. So if you can manage to make sure your code is testable, that's going to be a big thumbs up. And if you make sure it's cleaner as well, it's going to be easier to maintain and onboard new developers if you're not a solo developer and you're working in the context of a company. So thank you very much for joining the show. If you want to know more if you want to know more about architecture components, and I'm sure there's a lot more to cover, you can go to the official documentation at developer.android.com/arc, or this link, that's Arc Guide. It's a magic box. We don't know where it is from, but I'm sure you're going to find a few things from the architecture components there. So if you want to take this conversation afterwards, ping us on Twitter. Rebecca Franks can be found through Rigaroo, which also her blog, it's rigaroo.co.za. I can be found on Medium and Twitter as well through the same hashtag, same handle, Dario Mongoy, and Alex Collar Dev at Alex Collar Dev. So I'm going to hand over to Vivian now to kind of take the questions from the audience, and please keep them raining. And we still have somewhere around 10 to 15 minutes to make sure we ask these questions, but don't feel shy to take this conversation afterward. And we also have Google Developer Africa, Google Plus page that we can share later afterwards in the notes of this recording, that you can take the conversation there. Vivian, it's up to you.
Thank you, Dario, for the very nice presentations. So I'm still waiting for your questions, but I'll ask one question. Do we have to use the new classes?
So who wants to take that one? I can take it.
Well, I'm happy to jump in there as well, Rebecca, because I have actually just been working on a few apps where I've integrated only a few components, because I had heard that you can use them independently, but I wasn't sure about how well they would work. And it has actually turned out very well, just introducing view models into some existing code. So you certainly don't have to use any of them, in fact. You can continue to build your apps as you are, but you can also introduce just certain components from the architecture components into your apps and still benefit from it. So no, you don't have to, but you should.
You're on mute.
We have another question from Rosario. He asked if he wonders how you can use MVVM with Firebase.
Cool, I'll take that one. So you can basically put Firebase as sort of where we had in that diagram the different web services. So you would just typically wrap your Firebase database as part of either like a service or the database, and then create your repository. And on top of that, you create your view models that just then go through the repository and talk to your Firebase database. One thing to note though is that your Firebase database doesn't necessarily do the same thing as what Room does. So you might want to use the two together if you can. Because Firebase does offer an offline caching mechanism, you might think that it sort of works the same way, but you don't really get control over which things are cached versus which isn't. So it might lead to unexpected results. Whereas with Room, you can save exactly what you want to save within your database, and you know exactly what is there. And so I would typically say, take your information from Firebase and maybe cache it within a Room database and then use it from there. But obviously it's up to you. But Firebase with MVVM is definitely a possibility.
We have another question coming in. Do you have any examples of tests with these new architecture components?
I can take that one as well. Yes, so I can get this one. So I've actually got that one example that we did with the whole, with the event database, the event app actually does have tests on it as well. So it's got JUnit tests for the view models and I think for the repository itself, but the repository isn't too different from what we know before, from previous implementations of like MVP, for instance. So yes, there are examples. We'll share that as well within the show notes or via the event page afterwards.
Just to circle on that, if you really want to get a taste of how to do tests and have implement this Android architecture components, there's also the links to the Code Labs by Google, and they're kind of a really good resource to kind of know more about the architecture components, get a really good hands-on, and also have the opportunity to write some tests.
Thank you. A question from Dennis. He's asking, any drawbacks to the new architecture components?
Could take that one as well. So basically, as Alex was saying earlier, you're not really forced to use them. What we try to show is like how we feel about them, and basically we think that they do a pretty good job. So the only drawback that I see right now is if you have an existing code base that's really huge, might take a lot of time to kind of do the refactoring and so on. But if you're starting from a new project, I think it's definitely the way to go. And also make sure that another thing is that they're still in alpha, so a few things are going to change, specifically talking about the whole lifecycle aware components, where we're going to have some of these things embed directly into the support activity and the support fragment. So make sure that you're careful on that transition, but I think it's fine to implement. Just be mindful that's still on test, and as soon as it's live, go ahead full with architecture components. Rebecca, you want to add on that?
Yeah, that is similar to how I feel, Daria, but what I would add to that is the thing I like most about these components is they're very lightweight. So it's not likely to add many methods to your APK or to your file size, in fact. So that's one benefit. One potential place where you could run into some drawbacks or limitations is if you're replacing an existing ORM or data persistence library. It may not do all of the things you want it to do because some of the existing solutions try to do different things. So if you're trying to replace a different solution with this, you may run into some perceived drawbacks. That said, I think Room is definitely the one I'll be using for future projects because it's, again, lightweight, it's very fast, and it's testable. Even its migrations are testable.
Thank you. So I'll ask the last question. Should I use the Android data binding libraries with these architectures?
I'll take that one. So you don't have to, but if you are looking at doing MVVM, typically MVVM relies on the fact that there is some form of data binding. So I would advise using it, and it is sort of the best way to make sure that everything sort of flows correctly with your observables and your view model. And the data binding libraries have improved quite a lot since I used them last time. So there's a lot of work being done around them. So I would definitely recommend using them if you can.
We seem to have one last question. So have any of you had any success implementing the best observable interface into the view model class to integrate the data binding? Rebecca, do you want to take it?
Okay.
I can also comment on that.
Okay, let me do my comment first so that I can get out of this one. So I haven't actually tried doing the base observable interface yet. I've just been using the pure sort of view model and exposing it to the view interface.
Right, yeah, I was just going to mention that with the architecture components, I've been using live data almost exclusively because it provides that observability while tying into the life cycles. So it's easier to implement and more reliable in my experience.
Thank you very much. I think we don't have any more questions. Rebecca, back to you.
All right, so thank you everyone for joining and for your questions and for following us. What you can do is if you still have any more questions, you're welcome to tweet them at us and we'll try to answer them when we get some time. But in the next few days, we will be posting, there will obviously be this link available for you to share with your friends about watching the whole video on this presentation. And we'd also like to hear your feedback on the show. If you find it valuable, did you learn something from it? Should we continue? And any ideas that you have for future episodes. So if there's some particular topic that you would like us to cover, you're welcome to post that within the Google Plus event or on Twitter. Just let us know. And thanks everybody for joining us, and we will see you next month. Goodbye.
Keep rocking, guys. Cheers.